Another unusual tendency of water is that it expands when it freezes, which is very strange compared to most substances. Most substances will shrink or contract upon cooling, which is what water does too when it's in the liquid form. But then after 4 degrees Celsius, which is close to the freezing point, it starts to expand again, and when it freezes into ice, it expands even more. And most other substances do not do that. This has some pretty important significances to living organisms and to life on Earth, which we'll discuss. So this crystal lattice, which is ice, expanding, forms this way thanks to, what do you guys think is the answer here? I'll give you one clue. It rhymes with Schmidergen bonds. How does this affect the density of ice? Well, the density of ice will be, pick one, higher or lower than the density of water. You pick. And how does this affect lakes and ponds? So let's take a little bit closer look at this water expanding when it's freezing. So on the left here we have visual representation of what water molecules would look like in an ice crystal in the solid form. Okay, and what we see here is that the hydrogen bonds that form between the water molecules cause the water molecules to be spaced out a little bit into these funny sort of hexagons, which causes water to expand slightly, causing its density to go down, which makes ice float. Whereas in liquid water over here, the water molecules are actually closer together. There's still hydrogen bonds between them, but they're not regular. They're kind of all over the place, sort of randomly dispersed. And the water molecules are able to get closer together, which causes it to be, causes it to constrict and causes it to be more dense. So we have to think about, where does ice form on a lake? And the answer is it forms at the top. Even if ice formed at the bottom, if somehow that could happen, or if you took ice to the bottom of a lake, it would float to the top because it's less dense than liquid water. The reason ice actually forms at the top, though, is because the surface of the lake in the wintertime is the coldest. And that's where the water has the ability to freeze, because it reaches 0 degrees first. The ice then stays at the top and slowly works its way, the ice crust or whatever gets thicker and thicker and works its way down, but it doesn't start at the bottom, and the ice doesn't fall down to the bottom once it freezes. So if we take a look at this picture right here, this fourth diagram right here, that's the one we're going to focus on. The rest of them are different seasons, but here we're in the winter. We notice that the ice forms at the surface, which is the coldest part of the lake. And then as we go down, it actually gets a little bit warmer, and 4 degrees is the very bottom of the lake, is going to be 4 degrees. And by the way, it's 4 degrees at the bottom of the lake in spring, summer, and fall also. But in the winter also it's going to be 4 degrees, because 4 degrees water is the densest. So what's the significance of that? And the answer is that organisms that live in the lake, living organisms like fish and worms and crustaceans and things like that, frogs, amphibians, will be able to survive, because if the lake was going to freeze solid, if the ice actually fell down to the bottom and started to work its way up throughout the winter, the entire lake would freeze solid, would turn into a solid block of ice, which would kill all the living organisms, plants, algae, and all the animals each winter. And that would be devastating to life. And since life, the way we know it now on Earth, started in the water, even terrestrial life, we say, well, we live on the land, this doesn't affect us. Well, we wouldn't even exist, because we evolved from life that came from the water, which was able to evolve and progress over time, because these lakes and these bodies of water allowed the living organisms to survive the cold times during the winter.